Okay, homework help for section 9.4, day 2. I'll take a look at 3 problems. Going to do another problem where we do some mathematical induction. This time we're going to prove that 3 is a factor of that formula. Second problem I'll take a look at is writing a quadratic model, in other words a quadratic equation, for a sequence where the 0th term is 7, the first term is 6, and the third term is 10. And then we'll take a look at writing a repeating decimal as a rational number in terms of a fraction, simplified fraction. Alright, so getting a little bit more practice with this mathematical induction. This problem is asking us not to prove a sum, but to prove that a number is a factor of this formula. So remember there was 2 things that we were supposed to go through. We were supposed to assume that it was true for when n was equal to 1. So when n is equal to 1, I've got 1 cubed plus 6 times 1 squared plus 11 times 1 plus 6, which is 1 plus 6 plus 11 plus 6, or this looks like it's 12 and 12, so 24. And clearly 24 is divisible by 3. It's going to give me 8. So because that goes into 24 evenly, I can say yes, 3 is a factor when n is equal to 1. Alright, so that checked out. For number 2, or the second step, I'm supposed to assume that well, here, let's say that this was equal to like p sub n. I'm supposed to assume that p sub k is divisible by 3. In other words, 3 is a factor of it. So that means that 3 is a factor of k to the third plus 6k squared plus 11k plus 6. So there's the assuming part. We're saying that 3 is a factor of, and then I just substitute k into that equation. We are trying to show now that 3 is a factor of p sub k plus 1. Or in other words, plugging in k plus 1 for all of those. So, here's our work for that. We are going to take k plus 1 to the third power, add to that 6 times k plus 1 squared, add to that 11 times k plus 1, and then eventually add to that 6. Alright, so now I need to multiply or FOIL that out, and that eventually will give me k cubed plus 3k squared plus 3k plus 1, and I'm using Pascal's triangle to help me, or you can easily multiply it all out together. Careful here, I'll do 2 steps at once. If I ignore the 6, that's going to give me k squared plus 2k plus 1. Multiply those all by 6, so k squared times 6 should give me 6k squared. It was 2k times 6 will be 12k, and then plus 1 or times 6 will be 6. Distribute the 11 to get 11k plus 11, and still have the plus 6. And now if I combine like terms, I've got a total of 6k to the thirds. I have, looks like 9k squareds. I've got 3, 15, 26k's. And my constant, I have 1 plus 11, 12 plus 6, so 18. So this is what p sub k plus 1 is equal to. Now I have to show that it's a factor, or it's divisible by 3. In other words, that 3 is a factor of it. So what I'm going to do is I'm going to say, or look back here and say, we assumed that this was true, that 3 was a factor of that. What I'm going to try to do is rewrite this with this in it. So in other words, I'm going to say that k to the third plus 6k squared, I'm just rewriting this, plus 11k plus 6, so I basically copied that down, plus, now look what's missing here. I've accounted for the k to the third. There's a total of 9k squareds here. I only have 6 of them, so I'm going to add a 3k squared here. There's supposed to be 26k total. I only have 11 written down here in the next step, so I have to add on 15k to that. And then there's supposed to be 18 in this whole thing, but I only have 6 written down here, so I'm going to add 12. So I basically rewritten this as this plus this. And this, we just got done saying we assumed that that was divisible by 3. So I know that this is a factor of 3, or 3 is a factor All I have to do now is show that this is, and of course if you look at all those, you can factor a 3 out of it. It's 3k squared plus 5k plus 4, and because of that 3 times that quantity, that means that 3 is also a factor of it. And so because 3 is a factor of this chunk here, 3 is a factor of that chunk there, when I add them together I can say that 3 is a factor of p sub k plus 1, or the term that I would get when I plug k plus 1 in here. And there I have proven it. So a little bit different than the ones that we did yesterday, but similar in terms of the steps that you're running through. Alright, so the other problems. This one's asking you to write a quadratic model for the sequence when with the following terms. The 0th term is 7, first term 6, third term 10. Alright, so they said to write a quadratic model. Well, I know a quadratic model looks like this. ax squared plus bx plus c, and that's equal to f of x or y. So I'm going to use that and set up basically a system of equations with this. This is representing the x value, which means I would plug 0 in for all these x's. That would give me a times 0 squared plus b times 0 plus c is equal to, this is the actual y value, 7. There's my first equation. Plug in 1, I have a times 1 squared plus b times 1 plus c is equal to my y value of 6. Plug in 3, it's a times 3 squared plus b times 3 plus c is equal to 10. And this would be my system. Now it's not simplified, I'm going to go ahead and simplify it, but that's what my system setup looks like. Obviously anything times 0 is going to disappear, so I really know that the first equation is just saying that c is equal to 7. That's kind of nice. The next one, 1 squared of course is 1, so it's saying I have 1a plus 1b plus 1c, and that's equal to 6. And then the last equation, if I square this, would give me 9a plus 3b plus c is equal to 10. There is my system of equations all simplified. Now the nice thing is I already know what c is. I guess if it was me, I would take that and plug it in here and then simplify it down. So this would be a plus b plus 7. If I subtract the 7 over, that would give me negative 1. Same thing for this one. This is 9a plus 3b plus 7. If I subtract the 7 over, this would give me 7. And now I just have to solve that little 2 by 2 system. If you did end up with a 3 by 3 system where you have an a, a b, and a c, then remember that we did this in Chapter 7. You can use your calculator to help you figure this out. You'd have to do 2 matrices, one for the 3 by 3 matrix, one for the 3 by 1. Do the inverse of this one times that one. Alright, back to this. Obviously you can still do it with this if you want to. But back to this. I would multiply the top equation by negative 3 to say it's negative 3a minus 3b is equal to now positive 3. That way I can cancel the b terms. And adding those together, I should end up getting, oops, this is supposed to be 3. I think I said that, I just didn't write it. Adding those together, I would get 6a is equal to 6, or a is equal to 1. And now if I back substitute and put 1 in here, I can see that b has got to be negative 2. And so now going back to this equation, I know exactly what it is. I just have to put in a, b, and c. So a was 1, so it's 1x squared. B was negative 2, so it's negative 2x, and c was 7. And there's what my equation is. Whether you say f of x or whether you say a sub n is equal to n squared, it doesn't really matter. It's all the same thing. This is what the book is going to have, same thing. And you can obviously check it. You plug 3 in, you'll see that 10 does work. So there is a way to check it if you have time. Say this was on the test. Alright, so now write a rational number as a representation of a repeating decimal. In other words, write this as a simplified fraction. What I like to do is I like to take the part that's actually repeating and get that to be on the right side of the decimal place. So I'm going to move the decimal place over 1 to the right. Well, think about what is it that I'm doing to do that. I am multiplying by 10. That is important that I remember this, because I'm changing the actual number when I multiply it by 10, so I have to remember to fix it because that's not going to give you the right answer. Alright, well what that's going to give me is 13.17, and now the part that's repeating is on the right side of the decimal place, which is what I like. So here's what I do. If I remember there's 2 decimal places repeating, that means that I divide by 2 nines. So 0.17 repeating is actually 17 over 99. Well, still have the 13 sitting in front, so this is really 13 plus 17 over 99. And since I'm going to have a final answer as a fraction, I would want to go ahead and multiply by 99 over 99 so I had a common denominator. So we'll go ahead and just quick pull out a calculator to help us multiply this one out. If you have to do it again on the test by hand, you can easily multiply this out. But it looks like that's going to give me 1,287 over 99 plus 17 over 99, which of course I can add together to get 1,304 over 99. Now that answer is right, it's just not simplified. Or, sorry, take that back, I'm just not done. I have now taken 13.17 and changed it into a fraction. Now remember what I did to start with. I multiplied it by 10. So this is actually not the right answer. I need to undo this, which means I need to divide by 10, or in other words, multiply by 1/10. So now I've kind of undone this. I multiplied by 10 to start with, I now divide by 10, so that kind of fixes my problem. And it brings me back to my original answer. So if I multiply by 1/10, I would still have 1,304 in the numerator. I would just have 990 in the denominator. And now that's not simplified because I can see they're both even. So if I divide both of these by 2, I end up with 652 divided by, if I take 990 divided by 2, it looks like it's 495. Now if you had to do this on the test, the numbers would be a little bit more manageable. And again, that might be a little hard to see if anything goes into it or not, but that's actually the final answer. You have a calculator, so if you want to check yourself on the homework, that obviously is okay. Take 652 divided by 495, hit enter, and sure enough, I've got 1.3, and then the 1/7s are repeating. Whoops. So there might be other ways to do it, but this is the way I like doing it. I like getting the thing that's repeating by itself on the right side of the decimal point. Alright, there is your homework help for 9.4 day 2. Feel free to ask for help if you need to.